Example 18 talks about a situation in which the snow turns to slush. So the coefficient of kinetic friction is going to be something greater than the 0.10 that it was in example 17. And our job is to find out what that coefficient is. The things that we know are that if velocity is constant, then acceleration is 0. And therefore the net force must be 0. I'll only draw the forces up and down the ramp since we know that those are the ones that count. And we know that this force of friction must be equal to this force of gravity in the x direction down the ramp. From the previous problem, we were able to figure out that the force of friction is mu times mg cosine theta. That is mu, the coefficient of friction, times the normal force, and the normal force being the component of the gravity that is in the y direction. We also know that the force of gravity in the x direction is mg times the sine of theta. Since the net force must be 0, and what is happening is a tug of war between these two forces, we know that those two forces have to be equal to each other. So we can very simply take our two forces, set them equal to each other, Ff equals Fgx, and then substitute what we know. When we then solve for mu, which is what our ultimate goal is, we end up with mu equals mg sine theta divided by mg cosine theta. The m's we see cancel out, the g's we see cancel out, and we get mu is equal to the sine of theta over the cosine of theta. Now at this point you could go and plug 30 degrees into the angle and solve this algebraically, or you could remember that sine divided by cosine is the tangent, and when you plug in 30 degrees you end up with mu being the tangent of 30, which is 0.58. Now if you remember at the beginning we were looking for the answer to be something greater than 0.1, and 0.58 then we know makes sense.